All right, so these are, you're right, this is a review, but I want to make sure you know this because I need these fundamentals solid to build on for the next section that we're going to cover. So, factoring. And I'm going to call that unmultiplying. Or undistributing. And that'll be really silly, and this is Jeopardy. Da, 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 da. What's Jeopardy? A show on TV. What do? You have to just guess. Kind of guess? What? Guess what, though?
The question. Yeah.
Okay, they give you the
topic
answer and they want the question.
Oh.
And that boy knows because he's got a nice sweatshirt on. Yeah, what a crazy game on Saturday. Anyway, so if we were to say, okay, here is the multiplication problem where this is the answer. And we are undistributing and unmultiplying. What did I distribute to get that answer? You think. Just yell it out. 3, good. X, good. Y, good. Those are the common factors. And if I get them all out, I get the greatest common factor. Right? Got to get them all out. Not just some of them, all of them. So then I'm again trying to predict what the question was. So if I multiply here and I get this, what do I need in that first spot? X. Okay, you guys fill in the other two spots. Okay, second spot, 2y. Last spot, 4. Good job. With that in mind, you do B. Okay, what are some of the ingredients that are common? 7's good. Okay, now xy isn't bad, but there's how many x's common? 2. And how many y's common? 2. Anything below this is common, you're right, but it's not the greatest. And as Muhammad Ali said, I am the greatest. And we can put in the signs, that might be helpful. What's left after I take out the 7x squared y squared in the first term? 2xy? 2xy? No, I think just 2x. We already have 2 y's already, right? Y squared, that's okay. And then the second term, I need a 4. I think I need another y because I only have 2 here, I need 3, right? And the last one, 3. Good. How are we doing? All right, so make sure you see all of the greatest. Make sure you fill everything in that's missing. Everything. Now, next one, I need you to see 2 groups. 1, 2. 2 groups, not 4. 2 groups separated by subtraction. In those 2 groups, what's common? This package. Right. Now, I'm going to take it out. 1 from each. 1 from each. Okay? This is wrong. Squared. That's wrong. Because look, you took an x out of here, an x out of here, an x out of here. Why didn't you write x cubed? Right? That's wrong. So you wouldn't do the same thing here either. But people do that all the time. So what I try to do is to warn you, because I really am on your side now. Day of the exam, I put the stripes on, I'm the referee. I have to throw the flag when you make mistakes. I'm sorry. Now, of those two groups, what's left in the first group after I take out the 2x plus 1? What operation is between the two groups? Subtraction. Very good. And what's left in the last group? Okay, now, if I were to invent math, if it was up to me, we'd stop now. Because then I can see what happened, right? We can see it here, and there it is. And we can see this here, and there it is. But I'm too young. I wasn't back existing when they made up math. And so they don't stop here. I wish they did. So I keep this. But what they do is, inside the brackets, they clean that up. And what do you get? 2y is good. Minus 3. Now, what many of you just did is the most common mistake in mathematics, not just in algebra. You see this? You see this? What do you get? Positive. It's positive 1. Negative 4 plus 1 is negative 3. Notice that now. Whenever you see subtraction, turn up your awareness and be more careful. All right? Now these, I went down too far, are going to look just like C. Right? Going to look just like C. When you see 4 terms, the idea is, let's group them. So this is a nice question. It kind of includes lots of skills at once. In the first two only, what's common? R squared. What's left? S plus 3. Good job. So taking the first two by themselves, grouping these 2 by 2, I have that. The last two have what in common? 5 isn't bad. Negative 5 is better. There's that sign thing again, right? We're going to get better at the sign thing. Negative 5 times what is negative 5s? Positive s. Negative 5 times what is negative 15? Good. Now, it is no good to factor by grouping 2 by 2 and stop. At some point, you have to factor the whole thing collectively. But now we go back to what we did here. In these two groups of the whole problem, what's common? S plus 3, and what's left? R squared minus 5. Okay? And if you have time, here's what you should do. Check your answer. What do I get here? 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 In factoring, you should never get any wrong because checking is so easy, right? Okay, you try B. Alrighty, group 1. What's common? M squared. What's left? Now, side comment. I know you'd rather write n minus 4. That just doesn't look right, does it? Don't do it. Don't do it. Leave it. Just leave it, okay? What's common in the last two? What kind of n? Positive n. Good. What's left? This is a clue that you're on the right track. If those two groups are the same, you were correct. If they aren't, you may want to play with that sign to see if that'll make a difference, right? What's common in the two groups? How many of them? One is common. There are two there, but one is common. So make sure you don't make that mistake, because I see that all the time. Stay with me. What's left in the first group? M squared. What's between the two groups? What's left in the last group? N. How are we doing? Good? When we distribute or multiply, right? This combination always gives us the first term. And this combination always gives us the last term. Last term. Third term. How can I multiply and make 48? Just yell out some possibilities. 6 and 8, keep going. 1 and 48, okay, keep going. 2 and 24, keep going. 12 and 4, keep going. 3 and 16, okay. And the order doesn't matter, correct? But this combination and this combination give us the middle term. Is that right? So of those choices, which one of these is going to work? You write that down. All right, so clearly x and x are going to work. And then I have 5 to choose from, so that this combination and this combination make the 14. And who were they? 6 and 8. And for some of you, this will help. I'm going to write the 6x here for that loop. I'm going to write the 8x here for that loop. To make a positive 14, they both have to be plus, which makes this a plus and this a plus. And then I'm not going to go back and erase any of that. I'm just going to leave it for those that need it. Okay? For those that can do everything in their head, that's fine. For those of you that have to write more stuff out, that's fine also. Okay? So, let's go on to the next page. And pick a letter that you'd like me to try. D? Okay, let's take a look at D. Whoa. So in D, here's what we'll do. And if you were taught other ways in Algebra 1 that you like better, I won't feel offended as long as you're getting them right. But if you aren't getting them right, maybe you could try this instead. Guaranteed, how do I make x squared? X and x. Okay, now for 6, I have 1 times 6 or 2 times 3, right? So what I want to do is I'm going to draw the loops now. And I'm going to visualize the numbers I'm trying. And I look at 2 and 3 and I go, that's not going to make it, is it? But what will? 1 and 7. Now, I put the numbers in only first. Or 1 and 6, I'm sorry. Someone said 7, didn't they? Messing with me. Is that right? 1 and 6. And then I'm going to write the combinations down here. And then I look at the middle term, and how do I make a negative 7x? Negative and negative. And so what's going to make this negative? The 1. What's going to make this negative? The 6. And I'm done. And I'll just leave all of that there. It's scratch work. It's okay. So why don't you go ahead and do the other 8. And I will warn you, some of them don't work. Alrighty, A. X plus 2, x plus 3. B. C. E. And what if I had x plus 2 and x minus 3? Would that bother you? No, because if you're multiplying, you can switch the groups. But if you had x plus 3 and x minus 2, that's wrong. Got it? Okay. This one, what we just said, right. And this one, and this one. And this one. Heck if we know, right? Maybe some fractions or radicals or some crazy thing, but we don't know. So, what do we call this? If you can't factor something like 7 or 11 prime, putting some ideas together, right? We've used that word before when you couldn't factor it, but it was a number. But it's the same thing. It's prime. It's a prime